So before we jump into building, I just want to go over my circuit here briefly and explain how it works. So we have basically 5 main components here. We have our power source, which is just a 9-volt battery. We have a voltage step-up board. We have our lights here, which are just 24-volt RGBW LEDs, the kind that come in a strip, and you just cut off how many you want. And then we have a MOSFET here to switch the lights on and off. And this is our capacitive touch switch, which is kind of the heart of this whole thing. So this is the capacitive touch switch here. It's this little tiny chip, and it's pretty neat. Basically, it's just a little switch that's activated when you touch this pad on the back, and it detects the change in capacitance when the internal capacitance of your finger gets close to the pad. The next component is our voltage step-up board. Like I mentioned, these lights are 24-volt lights, and we're powering them from a 9-volt battery. So we need to step up that voltage so that the lights will actually come on. So this is just a little voltage converter here. It's pretty simple. It just has a positive in and a negative in, positive out and a negative out. So I'll connect the inputs to my 9-volt battery, and then I turn this little gold screw here with a tiny screwdriver, and that will adjust the output voltage. It'll go up to about 30 volts, which is plenty, so I'll just turn the screw until it's up to 24. And I'll measure that on my multimeter before I plug it into anything. And then this will power our lights. However, I can't use the capacitive touch switch to directly turn on and off the lights, because if I run it between the output of the power converter and the lights, it'll fry the capacitive touch switch. This is meant to operate on like 3.3 to 5 volts. 24 volts will kill it. I tried one to be sure, and yeah, it does. So I can't put it after the board in the circuit. And I don't want to put it before the board in the circuit, because then I can only turn it on and off one color. And the point of using these RGB LEDs is I want to turn multiple colors. I want to have several of these touch pads going down the staff, and depending on which one you touch, it lights up a different color. So if I put the switch before the board in the circuit, I can't do that. I would just get one color. So I need to be able to use the output of this to drive something that will be able to switch the higher voltage. Now, my immediate thought was to use a relay board like this. This is a little breakout relay. But this thing is big and clunky, and fitting 7 of these into the staff would be a pain. I can get 7 colors out of this just with no extra logic, just turning them on and off. And I would like to use all 7, but 7 of these, that's going to take up a lot of room. And also they make the slapping noise when they close. We don't want that. So instead, we're going to be using this. This is a MOSFET. Now, if you've never heard of a MOSFET before, they're pretty cool. Kind of complicated how they work. I'm not going to get into that. There's lots of videos out there, I'm sure, about MOSFETs. Basically, all you need to know about it for the purposes of this project is that it's a transistor. That's what the T in MOSFET stands for. But the important thing is it has 3 terminals. It has a gate, a drain in the center, and a source. And an N-channel MOSFET, if you put a higher voltage at the gate terminal than is at the source terminal, it will act as a switch. So here's the MOSFET in the circuit. What I've done is I've connected the source terminal to the ground of the power board, and the lights run through the drain. Now the gate is connected to the output pin of the capacitive touch sensor. So when we touch the capacitive touch sensor, that output pin will go high. It will put 5 volts, or well, 9 volts because we're using a 9-volt battery, at the gate terminal. And that will put it into enhancement mode. It will act as a switch, and it will close that metaphorical switch between the drain and the source. So it will connect the drain pin to ground, and the drain is connected to the light's ground. So that will complete the circuit for the lights and turn them on. So all I have to do is connect this other side to power the battery, and then when I touch this, the lights come on. Off, on. Pretty cool. So I can run multiple touchpads to multiple MOSFETs. The MOSFETs are very small, they won't take up a lot of room, and I can have going all down the staff, all 7 colors. When I touch one, it will light up a different color. Now the only 2 other things in this circuit are right here. I'm not sure if you can see it too well, but there is a pull-down resistor. It's just a 220 resistor that I'm putting between the gate of the MOSFET and ground, because when I didn't have it there, I would touch the sensor and it would just stay on. So that resistor is just going to pull the gate back down to 0 volts after we let go of the sensor so the lights turn off. And then the other thing is I just have a little tiny switch here. I scavenged this off with something, I'm not sure what, but it's just a toggle switch. And I'm going to put that between the battery and the voltage board, because this board will actually draw power even though, even when the lights are off. So this circuit looks like it's off right now until I touch this, and then it comes on. But even though it's off, it's actually still drawing power from the battery. So if I just left it like this, it would kill the battery really, really quickly, and I don't want that. So I'm just going to put a switch there so I can turn it off when I'm not using it. And that's the basics of this circuit. The first thing I did was take a paper towel tube and cut off a piece that was the same size as the 9-volt battery. I wrapped the cardboard around the battery and glued it to itself so that it would still slide out. Then I took a dead 9-volt battery, and using snips and pliers I pried the top open so I could cut the terminals off. Then I took some longer wires and I soldered those to the underside of the terminals to make a sort of DIY 9-volt battery connector, since two 9-volts will connect to each other. I'm doing all of this to make a sort of removable housing for the 9-volt battery in case it ever dies. It would really suck to finish this whole project and then have the battery permanently stuck inside. So once I finished the battery housing, I hot glued the voltage step-up board to the outside of it, and then I soldered that to the battery and the switch as well as some other leads. Then I took a little time to test the circuit, and it was then that I noticed I had a problem. So I realized something that I failed to think about. I mentioned earlier that I was planning to use 7 color combinations that the RGBW LEDs are capable of. And the RGBW LEDs have 4 LEDs in them, basically. They have a white one, a green one, a red one, and a blue one, RGBW. So I got those 4 colors, and then I can make yellow, cyan, and a pinkish purple by combining some of the colors. So, for example, if I press this one, we get green. If I press this one, we get red. If I get green and red, we get yellow. But I want yellow to be on a separate switch, right? So this should be the yellow switch. That means that I need to connect the MOSFET from the yellow transistor, or the yellow sensor. I need to connect that to both the red and the green LEDs. Right now it's just connected to the red. Because here's the problem. If I take this wire and I connect it from the red over to the green, this is what I was planning to do. This all worked in my head, right? Now look, oh, I press one switch, yellow light, except here's the problem. Wires work both ways. So those are just connected now. So this switch does yellow, but so does this switch, and so does this switch. And now, no matter which switch I push, it's just yellow. I don't know why I didn't think of this, but I didn't think of this. What I need is to connect the yellow switch and the other 2 switches that will be multicolor switches. I need to connect them to the leads for the LEDs, but I need to do it through a diode, or actually through 2 diodes. That way the electricity can only flow in one direction, because I don't want current going back up the wire when I touch one of these switches and it's still connecting. It won't do that if I use diodes instead of wires. I don't have diodes. I do, however, have light-emitting diodes. So I'm going to take LEDs and I'm going to use them as diodes, because they are diodes. They just happen to light up. And then I'll cover them in tape or something so that you don't see light shining through the bottom of the staff. But that way, I don't have the backflow and they'll all just be the same color. I should be able to get all 3 colors. So if I rewire this... Okay, so if I rewire this through 2 diodes instead of just through a wire, I now can do green, yellow, and red all separately. So, if you decided that you want to try to put this together, don't forget the diodes. I will make sure to include the diodes in the circuit diagram. I've already started adding them to figure out how they need to go in there. So now we can do colors individually and not just yellow no matter what we touch. So once I got that problem taken care of, I started making a top for the staff that would unscrew so that I could access the battery. And to do that, I decided to use an old vitamin bottle. So I cut a little door in the side so that I could stuff the electronics inside, and a hole in the top so that I could fish wires out of it. Then I was going to also cut a hole in the lid and screw that part to the staff. Speaking of the staff, let's take a quick break from the electronics to talk about that. So this is a branch that I found in my woods. It was very straight and mostly devoid of bark, so I thought it would work great for this staff. I cut it down to length, and then using a bandsaw, I cut a chunk out of the top so that I would be able to chisel a channel out for the wires. Now what I'm doing here is I took the symbols that I was going to use for the touch pads and I laid them out on the staff, and I'm marking with a pencil and an X-Acto knife where the holes for the wire should be drilled so that when the wire pokes through, it's behind the symbol and not behind any negative space where there isn't any foil tape. Now I had cut these symbols out of the aluminum tape using my Cricut, but I'll talk more about that later. So as you can see here, I'm just drilling the holes for the wires to poke through, and then once I drilled the holes, I went on the other side using a much larger drill bit and just hogged out a lot of the wood just to make it easier to chisel out the remaining material so that I would have a nice channel for the wires. Now, a quick disclaimer here while I'm chiseling. You might notice that the footage is going to start jumping around a little bit, and that's because I made a pretty big mistake later in the process that led to me having to redo a lot of these steps. Once I finished chiseling out the channel for the wires, I went about actually fishing the wires through the holes that would go behind the foil tape. Now, as you can see here, I'm dealing with a giant mess of wires. That's because I'm redoing what I did the first time and I'd already soldered things together. So don't mess up like I did the first time. It's very important to have short wires running from the foil tape to the touch sensors. I'm gluing the touch sensors in place right behind each foil tape pad. The first time I did it, I had long wires that ran all the way up the staff, and that mass of wires in close proximity just caused a feedback loop with the touch sensors. It turned the whole thing into a crazy headache-inducing disco. So for take 2, I made sure to use as short of a wire as I possibly could, and for added measure, I soldered them directly to the touch sensors. Now, in order to do that, I had to use my Dremel with a sanding bit to expose a bit of the copper so that I would have something to solder to. Also, now that I had more wires running up the length of the staff, I had to chisel out the opposite side of the piece of wood like you see me doing here. The first time I did it, when there was only one wire from each sensor, there was plenty of room, but this time I had the power, ground, and the output from the touch pads all running down into the staff, and I needed the room. So once I got everything set, I electrical taped it together to run a test because I didn't want to glue it again and then find out that it didn't work. So I just soldered everything up for a quick test, and once I verified all the colors were working, I was ready to glue it together. I only used a very small amount of glue just in case I ever needed to break it open again, and my dad helped me out here, providing an extra set of hands to help me wrestle the whole thing into the clamps while it dried. Once the glue was dry, I stuck on the symbols. Like I said earlier, I cut these out of the foil with my Cricut, but you could do it with an X-Acto knife, especially if you chose to use less complicated symbols than I did. I chose to use the symbols from the 7 Schools of Magic in the really old MMORPG Wizard 101 because there were 7 of them and they matched my colors perfectly, and also I to this day still love that game. They were a little tricky to cut out though. I actually couldn't use an image and ended up having to freehand draw them with much thicker lines so that the Cricut wouldn't rip the tape when it was trying to cut them out. I found the best way to stick the symbols on was to use tweezers and an X-Acto knife to remove all of the negative space and then place masking tape over the symbol before I pulled off the sticky back and stuck it onto the staff. It took a little while, but eventually I got them all on and lined up covering the wires. Now I was ready to build the head of the staff, which meant that I needed to first attach my battery compartment. I took the lid from the vitamin bottle and I screwed it onto the wood. Then I cut a hole in it and the top of the bottle and fished the wires up through the whole thing. Then I took my battery and voltage board assembly, put it inside the bottle and fished those wires out the top. Then I closed my door on the bottle and I taped the whole thing shut with a lot of masking tape to keep it in place. After considering a couple of different designs for the top of the staff, I decided to go with a dragon's head that was holding the crystal ball in its mouth. So to construct the skeleton for the dragon, I used popsicle sticks and hot glue. I got to work cutting a whole bunch of popsicle sticks in half, and then gluing them together to make the curve of the neck. I layered the popsicle sticks about 5 thick, overlapping each layer on top of the previous one to make the whole thing nice and sturdy. At the base of the neck, I layered the popsicle sticks even thicker to make a nice foundation where it would attach to the rest of the staff. I also cut these popsicle sticks at about a 45-degree angle so that they would sit flat on top of the vitamin bottle and still have the nice arch of the neck that I wanted. I glued this popsicle stick creation to the top of the staff, and then I taped it in place with masking tape to hold it while I glued more popsicle sticks to the side and back for support. And just for added measure, I wrapped even more masking tape around the bottom. Next, I constructed the jaw by the same process. I cut a whole bunch of popsicle sticks in half, and then I layered them together until I had two pieces that were both the same thickness as the neck, and then when I glued them in place, I glued pieces on the outside that were overlapping. I test fit the crystal ball inside the jaw before I glued the bottom piece of the jaw in place, and then I secured the crystal ball by putting half of the toothpick into the ball at each end and gluing it to the jaws. The thing that I'm using for a crystal ball, by the way, is this little decorative orb that I found at a craft store a while ago. It's kind of rubbery and feels like it's made almost of hot glue, and it has all these little holes in it, so the toothpick slid in very easily. And it was also very easy to cut a hole in the back to fish my lights inside. Anyway, once the dragon head was done, I soldered up the electronics, and then I taped all the wires down to the skeleton with masking tape to hold them in place. Next, I started building up another layer around this skeleton by taking a wrapping paper tube and cutting off pieces that I would wrap around the dragon's neck and masking tape them in place. This layer was going to serve as a base that I was planning to glue tree bark to because I wanted the dragon's head to kind of look like it was made of tree bark. I don't know, I just thought that would look cool, and I knew a tree that had some bark falling off. I also took some flat pieces of cardboard and cut them around the crystal ball to make the sides of the jaw. I wanted this area to have a little more volume, so I built it up using even more layers of the flat cardboard. I also cut some longer strips and wrapped them around the front of the jaws just to smooth that area out. For the eyes, I took two large googly eyes, and using an X-Acto knife, I cut around the base to remove the white part from the clear part of the eye. Then I made a mound of sticky tack and I pressed the clear part into it. The reason I'm doing this will become clear shortly. I colored in the white part of the eye with a bright green Sharpie because I wanted my dragon to have green eyes, and then I took the black pupils and I cut them into more dragon-like slits and I hot glued them carefully into the centers of the white part. Then I filled up the clear part of the eye with hot glue and I placed the white part back on top very carefully using some sticky tack on the back as a handle. Once they were cool, I pulled them out of their sticky tack molds, and this was the result. I glued the eyes in place, and then I painted over the masking tape and cardboard with just a layer of black acrylic so that any gaps between the pieces of bark would be dark and not the color of masking tape. Now it was finally time to cover the staff in bark. I collected these larger chunks from my woods where this tree is just losing all of its bark. I think it was struck by lightning. Anyway, I broke them apart into smaller pieces and then just kind of puzzle pieced them onto the staff wherever they fit, but unfortunately I ran out before I finished. So, I have run out of bark for my staff because, as usual, I didn't collect enough, so I'm going for a little walk to the tree where the bark is just kind of falling off. So that would be this tree right here. As you can see, the bark, it's kind of just flaking off. So I brought along a tall stick, and I'm going to try to poke some off. See how that goes. This is a pretty big piece. I'm hoping it will be enough. And then the smaller piece also fell off. I don't have that much more dragon to go, so I'm hoping that this will be enough bark between these two pieces. Let's go find out. The second time I had plenty of bark, so I just continued covering the dragon, putting on pieces like a fun puzzle made of trees, until I had covered all of the surface area of the dragon. When I got to the detailed areas around the face, I was sure to pick bark and place it strategically around the eyes to look kind of like angry dragon eyebrow ridges, and I cut some triangular pieces to be fangs and glued those onto the crystal ball. I also found some longer pieces to be dragon horns, which really went a long way in making it not look like a snake. To attach the horns securely, I actually drilled a hole into the bark at the thickest point, and then I stuck a nail inside before I hot glued it in place to give it a little extra stability. Well, here it is. It is finally complete. The finished, light up RGB wizard staff. yeah, so it turned out pretty good. I'm very happy with how the bark looks on the dragon. The electronics are still a bit finicky, and I'm not super happy with that, but I don't know what it's doing. So if I turn it on, the switch is right here. This is where I ended up embedding it. If I turn it on, I can do each color. Let's see, right away it got stuck. It gets stuck sometimes, and I don't know why it's getting stuck. It's got to be some kind of feedback that it's causing with the capacitive touch sensors, but I can't figure out what it's doing. I mean, I spaced them out in the handle. The wires connecting them to the metallic touchpad are very short, so I don't know what's causing the feedback. I don't know if it's something to do with the diodes for the multicolored colors, the ones that take more than one LED. Could be something with that. Not 100% sure. Turning it off and back on again seems to fix it, and then I can go back to using each individual color. It's also, they're a little touchy. Like, I don't have to touch them. I can get, if I can see if you can see how far away I can be. You can mess with the sensitivity of these sensors by, there's a terminal that you can solder a capacitor onto to make them less sensitive, but I didn't have any, it's just blinking randomly now, I didn't have any capacitors of the right capacitance on me to dial in that sensitivity. Apparently it's a very specific range, or else they just don't work at all. If you put too big of one on, they just don't work. Also, I think it might have helped to maybe put these symbols a little further apart on the staff itself, because it's hard to touch one and not be touching another one or not triggering another one, just because they're so close together. So I think spreading them out further down along the staff might have also helped. So it's not perfect, but all in all it turned out pretty cool. I mean, it lights up when you grab it, and even if you just kind of like wrap a hand around the staff, it ends up lighting up white because it's lighting up, in most cases, like all of the colors at once, which is just going to show up as white. So like, that's cool if I just grab it and it lights up white, which wasn't the intent, but hey, this was an experiment. It was a work in progress, and aesthetically it looked really cool, even if the electronics are a bit finicky. Still not 100% sure what happened, because it was working well, like they were all working before I started putting the bark on, so I don't know if just something inside is causing a problem. I have no idea, but anyway, this is the finished staff. I hope you liked it, and I hope you liked seeing my process. If you did, be sure to like and stay tuned for my next project.